So, good evening, one and all. Today, would like to discuss about deep learning on neural network. So, my name is Venkatabhiram Shebrulu, and um, welcome, one and all. So, here we can discuss about the. So we're building the neural network, so using our data set. So as usual, we are importing all our libraries from TensorFlow, importing conveys. Like this is the main TensorFlow library, and also we are building a neural network with several hidden layers. So here we are printing the current TensorFlow version you can find, and we are numping all our importing all our numpys, pandas, matplots for visualization, seaborns, and here we are reading in a data frame. See here, so is here we can find the current TensorFlow version 2.5.0 and all my attributes. Here, and I'm calculating the race number. I'm giving the race number as adult.race, and also I'm getting the output like here race num here, which is object, and also race is object and race num is integer 8, and my dataset type is an object, and I'm using adult.head. You can find all my attributes here, and I'm calculating my mean of my adult income. So you can find here mean of my adult data set, which is 56583.900, and also calculate median and mode. Here you can find all my outputs. So after that, I'm reducing the data like pre-processing. So I'm taking list of attributes, all my attributes: age, education, years, race, num, house, peaks, works in user income, and here I'm encoding the categorical variables like here race, num. I'm using prefix. You can find here, and after that I'm splitting into training and the data set. I'm using all my attributes here, list of attributes, and importing the standard scalar. For that here now we're going to building our model with like setting 80% and 20% x-axis, y-axis, text size, and just like 0.2. Here you can see the text train shape, x test shape, and also after that here I'm going to like we're going to like separate the features from the labels. We are going to predict income, splitting the feature labels like train futures, test futures, income USD labels, and normalizing the data. I'm accessing using -1, printing like a mean. I'm calculating the mean here. I printed the mean numpy, and with this mean numpy, here I'm getting the original data and normalized data. You can find here the output. A list of original data and normalized data. Coming to the fourth question, I'm building the network architecture. First, we have to build the normalized layer. I have taken the age, and then input size 1, axis none, and after that now we can build the framework that hold all the models. Here you can find my output model mode 1 sequential, and also I'm compiling that using the built-in method. Suppressing log, and also after that I'm calculating the validation results of 20% of the training data. Like that means we test as we go on 20% subset of the training data, and I'm getting the CPU times as well, and I have taken the x-axis and y-axis here. You can find my graph here, and also the test results. Got the output age model, and also using the multiple variables to predict the income USD in a simple neural network. So you can find all my linear model is a list of one linear model, and also using the .compile built-in method. So I'm compiling, I got the loss, mean, and percentage time here, and calculating the validation results of 20% of the training data here. This is all my result with the test results linear mode 1, and also deep neural network DNN. Here we're setting up the keras architecture, normalizing the function. First hidden layer 64 nodes. Here the second hidden layer also the building with the relay function. Dense layer for a single output because we are working on regression and we are done with the building the model now. Here I'm configuring the runtime for our model. The loss function is mean absolute error, makes sense of regression. You can find all my total parameters 4356, non-trainable params 3, and here we can find the percentage time data, and you can find the plot is x comma y-axis here, x-axis and y-axis income USD and age, which is the predictions and the data, and the result is test results. You can find the linear model, multiple variables here, and I calculated the multiple test predictions here, true values, x-axis and y-axis, predictions and the true values income USD. You can find the graph here, and then I got the array of a list of array, and data type is a float. Test the results, I got the float, and also using a softmax in the output layer to identify the class membership. You can find the I got the array of a list of data type is object, and logic list of float numbers. You can find the sum of softmax and all everything, and also compiling the model to run with the batch size of 32. Here you can find all my percentage time. This is all my data, and also x-axis y-axis predictions income USD and true values income USD. Taken 0 and 50. You can find the graph, and finally we're going to build the confusion matrix and classification report initializing by initializing the multi-layer perceptron, running this with all the default setting, using the 100 and 200 maximum iterations, and also running in a verbose mode so we can see the output of the each iteration. As this runs in verbose mode, note how the loss function steps down with every single iteration. I'm taking the x-axis and y train, like all my iteration. This is the, so here I'm getting this course, take a future matrix x test and expected target values y test, printing the value 1.0, and x-axis and y-axis are true label and predict label. You can find here the what predictions look like, printing the tested predictions, a list of integers here, prediction, and importing the metrics from sklearn, all my perception, recall, F1 score and support. Accuracy is 1.0, macro average and weight average, and accuracy score on output analysis. You can see my data accuracy score is 100% accuracy. I'm printing the output analysis. That's all. Thank you.